Give the structures A through D and the following synthesis scheme. So for a scheme like this, okay, you can start from A or you can look at the product that's given to you, which is really fantastic. So you have something to at least look for as your target, okay, and then you can work your way backward also to figure out the structures of A, B, and all that. So that's what we are going to do here, because of course, if I'm giving a structure, why shouldn't I look at that structure? All right. So this is just a scheme of reactions, a very common kind of a question. All right. So let's start working our way backward. Okay. So we'll start with D. We don't have to start with A. All right. We just want to make sure that we have the right kind of structures. Okay. For everything. So when you look at something like this being added, okay, to something like D, and then you're also looking at NaNH2 over here, so which you know is actually a very strong base, so which means that you knew that you were starting with something that was acidic to begin with. So, and here you can see a triple bond, and you're adding 2 carbons to that triple bond, so it's possible that 1, 2, 1, 2, these 2 carbons are actually coming from that iodide. Okay, and so maybe D is going to be all of this, okay, over here. So let's go ahead and write our structure out. So we have a T-butyl kind of structure here and an alkyne, and remember this was a strong base, the NaNH2, which means that this is what I should probably have here. Okay, so the strong base means reacted with an acid, which means that I need to convert this one D into an acid, so which means that C is not really very different from D, it just has the hydrogen also on here. Okay, so that's going to be the structure of C, because I know C, when treated with a strong base, will give me D. Okay, so then what could be the structure of B? And the structure of B, I'm looking at the reagents that I'm using here. I'm using excess of NaNH2, which tells me that I actually have a strong base and I have a leaving group. Okay, so I'm looking at the reagents before, and yeah, okay, Br2 is actually leaving groups. All right, so which means that for the alkyne over here, I must have leaving groups. Okay, so now I can draw my structure out, and so here is the T-butyl kind of a group, and then I have 2 more carbons, so 2 more carbons, and then excess NaNH2, which means that I must have bromine over here. So that much is true, and then the only way I can add bromine to A is if A had a double bond. Okay, and so the double bond will of course have to be on the 2 carbons that had the bromine on it. So that means A should be, technically speaking, sorry about that, let me try that out again with a proper pen. And here we go, so 2 carbons here, so it means this must be an alkene. So all I need to do now is make sure that this is C6H12, so I need to make sure that I have the right number of carbons, and so let's see, 1, 2, 3, 4, 5, 6, and 6 with a double bond gives me C6H12, so I have the right formula there. Okay, so just because you're given a structure from A or you're asked from A doesn't mean you have to work from A. Okay, so work your way backward in order to get the answer. So this is the scheme.